All right.
Every 4 words, and then Biden just couldn't answer the question. Yeah.
Okay, guys. Today we'll start by taking any questions that you guys might have from the previous homeworks. So if there's anything from the previous assignments that you want to ask about, now is a great time to do that. So I think last time we assigned a couple problems from the book, and then there's a worksheet. But anything from any of those 2 locations would be perfectly reasonable to ask about, but you don't have to if you don't have anything. So we'll pause here for a minute in case you're looking through things to find what you're looking for. I'm not in a big rush, but after a minute or 2 of looking, I'm just going to move on and we'll start what we're going to do today. It doesn't mean you can't come back and ask questions about these things later. But we're going to start, I guess, the new stuff unless anybody wants to jump in right now. Okay, so that's fine. So today we're still in section 3.1, and the idea here is we're going to go from a graph or information about the graph back to the equation. So this is what we're going to do today. So we're going to look at the graph of some kind of sinusoidal function and translate that back into a sine or cosine equation. Okay with that plan? So let's just look at some examples. We'll look at a couple of graph examples, and then we'll look at a couple of information examples. All right. So I apologize about the resolution on the axes there. I thought this picture would turn out better than it did, but basically everything is going from -2 pi to +2 pi, and then the intervals are, or the tick marks are halves, and the y's are just going up by 1s. So our goal is going to be to write something in this form, or an equation in this form. So those are kind of the general form for a sine or cosine function, right? So in order for me to do this, I need to figure out the values for a, b, h, and k. So I'm going to just do that by looking at the graph. I should be able to get all the information I need just by looking at the picture. So I'm going to zoom back in here a little bit. So remember, for the amplitude, let's use it, is related to the A coefficient, right? This was something we established yesterday. So if I can figure out what the amplitude is on the graph, I can figure out the A. Everybody okay with that plan? All right. So remember, the amplitude is half the distance between like the highest point and lowest point on our graph. So that amplitude here is basically that distance divided by 2. Is everybody okay with that? So I count 1, 2, 3, 4 units. And if I divide that in 2, I get 2. So I know A is either 2 or -2. Is everybody okay with what I did there? Okay. I know that K is related to the midline, in that Y is equal to K. The midline here should be easy to see. What looks to be the midline? Yeah, the x-axis, right? So remember, the midline divides the graph in half, basically. So we can say that K is 0 there. We remember that the B value is related to the period. So I remember that the period is 2 pi B, or absolute value B, I should say. And a period is basically one cycle for my graph. So if I look at the picture I've drawn, basically that's all I have here. It's just one cycle. Everybody agree with that? Where we start on the midline, we do an up, we do a down, and we end back on the midline, ready to start another up section. So the picture I have is just one cycle itself. So basically from here to here is one period. Everybody agree with that? So if I count there, we're starting at -2 pi, and it ends at +2 pi. So my one period is 4 pi. So that tells me the B value has to be 2 or -2. Elizabeth. So this tick mark down here is -2 pi, and this one was +2 pi. So it's just hard to read, but 4 pi of distance. Is that cool? Okay. There are 8 tick marks in there, but the tick marks are half a pi is what the graph reads. And you can't, obviously, you can't read that from back there. I bet Teresa probably can't even read that from up in the front. So you'll just have to take my word for it. On your homework papers, it'll be clear. The picture will be better. I stole this from somewhere else, and the resolution wasn't very good. You know, what can you do? Sometimes you can't do anything. Okay. So far, so good? Now comes finding the h. So if we're looking at a sine function, we're going to find our h one way. If we're looking at a cosine function, we're going to find our h a different way. Okay with this plan? So far, so good? So the idea here, if I'm looking at a sine function, remember what the parent function looks like for sine? That it looks like this, right? Everybody's remember that? What I'm going to take is this key point at 0, 0. That key point there from the sine function is on the midline, right? So what I'm going to do is I'm going to go back to my graph, and I'm going to choose one of the midline points for my graph. Victoria, looks like your tablet's ready or some such thing. So I could choose this point, I could choose this point, or I could choose this point. Does it matter which one I choose? No. Which one would be the easiest one to choose? Whoa, hang on tight. The easiest one to choose would be the one that's at the origin, where really no translation left or right or up or down has happened. Does everybody agree with that? So the idea here, and I'll write out what it is that we're doing, just to be clear, is I'm taking my point 0, 0 from the parent function, and I'm transforming it to the point 0, 0 in my new function. And I remember to do that, what I do is bx plus h, where this is the x, should give me my new x coordinate over here. And since we have a 0 there, h is just 0. So whenever I'm doing this, whenever I'm finding h, I'm always going to use this midline point from my parent function because it doesn't depend on b. Since that x coordinate is always 0, the x coordinate from my transform function, as long as the point that I'm picking from my transform function is a midline point, will be my h value. So it just allows us to kind of avoid a little bit of arithmetic, but it's reliant on choosing a midline point to do that. Is everybody okay with that answer? So if we put this all together then, we have one more decision to make before we can put this all back together. We have to determine whether our A's and B's should be positive or negative respectively. Okay with that plan? Remember we said it could be 2 or negative 2 for each of them. So what I'm going to do is I'm going to compare my picture to my parent function. So if I look at my picture, I have a up and then a down. My parent function starts with a down and then an up. So what does that tell me? It tells me that a reflection has taken place, right? What kind of a reflection has taken place? It's across the x-axis, or it could have been across the y-axis. But it couldn't have been across both, right? If you reflect both, you're going to be back where you started. So it turns out it doesn't matter whether we want to pick a negative A and a positive B, or a positive A and a negative B. You just can only have one of each, and we'll get the same picture. Is everybody okay with that idea? So I usually always pick the B to be positive. It tends to make life a little bit easier. In future problems that may be a little bit trickier than this particular one was. So our answer in terms of sine could be this. Is this the only answer I could give? Well, definitely not. Remember, we could have swapped the signs on the A's and B's and still had a correct answer. So is that the only other answer I could have given? Definitely not. Remember, we had our choice of all these different midline points that we could have picked, which would have given us different values for h because they have different x coordinates. So I could have had like x minus 2 pi or x plus 2 pi inside of my sine function here, because the h could have also been 2 pi or negative 2 pi. So there's lots and lots. In fact, there's infinitely many correct answers. You just need to supply one of, or a possible correct answer. And when I'm grading these, usually if it's not what I'm expecting, I just graph it with the other thing that I know the answer to on there and just check to see if it actually overlaps it or not. It's easy to do if I'm getting something I'm not expecting. Okay? Let's do this now with the cosine. So the cosine, nothing changes in terms of figuring out what A would be, figuring out what K would be, or figuring out what B would be. Those will all remain the same. The difference is going to be figuring out the H. So our parent function for cosine kind of looks like this. The point that I'm going to be interested in from the parent function for cosine is this one, because the x-coordinate is 0 here. So what that means is, what sort of points am I going to be interested in from my graph? I'm going to be interested in the extrema, the maximums or minimums. Is everybody okay there? Now, here, the choice of whether I am going to choose a maximum or a minimum is going to immediately dictate my sign for A. So if I'm going maximum to maximum, my value for A must be positive. If I'm going maximum to minimum, my value for A must be negative. Is everybody okay with that idea? And hopefully that makes sense, right? Because if we're starting with a maximum in the parent function, but we start with our minimum in the transform function, we had a reflection across the x-axis. Yes, Josh? I meant to write 0, 1. Thank you. So for the sake of argument, let's pick this point here that's negative pi comma 2. Since we're picking the maximum, that forces our A value to be positive. And just like before, if I think about how I get negative pi, well, I have to take my x-coordinate of 0, multiply it by b, add h to it, and that should result in negative pi. Well, 0 times b is 0, so 0 plus h is h. So h just has to be negative pi. Is everybody okay there? We have one more decision that we need to make before we can write our final answer. We still need to decide on the sign for b. But here's the thing. If I look at the parent function for cosine, it kind of looks like this, right? If I reflect that across the y-axis, does it change anything? No. So does the sign for b matter for a cosine function? No, it doesn't matter at all, right? If we reflect that graph across the y, we end up with the same thing. So we'll just pick one. I always pick the positive one just because it makes life a little simpler, because we have one less negative sign rattling around in our equation. But there's nothing that requires that. So now if we put everything back together, This is one possible answer. Yes. So because this point here is a maximum in my parent function, right? It's this spot right there. And the point that I chose was a maximum on my graph. Tells me that there is no reflection across the x-axis because I started with a max and I'm getting another maximum. So that part tells me that the A has to be positive. If I had chosen the minimum to map to, then A would have to be negative. Does that feel okay? You're welcome. Let's do another. Sound okay? Am I going too fast? Is this okay? So it's not, I mean, this is tricky at times to get the hang of to start, but once you've got the hang of it, hopefully it's not too bad. And it's one of those that, like, even in the beginning, there's parts of it that are pretty easy. Okay. So this one, the scales are the same as the previous problem. So the x's are going from negative 2 pi to positive 2 pi, where each tick mark on the x-axis is half a unit of pi. And the y's are going up by 1, so just 1, 2, 3, 4, etc. What does my value for A have to be? Anybody want to remember how to do this? What was that? Negative? Well, there's two possibilities, right, for A. 1 or negative 1. So remember, A is half the distance from a high point to a low point. So that's 2 units. If I take 2 units and divide it by 2, that's just 1. So the amplitude was 1, so our A value has to be positive 1 or negative 1. Is that okay with you guys? What's our value for K have to be? Positive 1. Very good. So the K is the midline. Should be easy to see that y equals 1 should be the midline. Is everybody okay there? So far, so good. Okay. Now let's try to figure out the B. So here we need to look at the period. So here we have lots of periods of the graph. I think when in that sort of situation, it's easiest to just go from like max to max or min to min. So that distance will represent one period. So if we go from a half of pi to 3 halves of pi, how much distance did we cover? 1 pi, right? Is everybody okay with that? If we go from a half to 1.5, we went 1 unit. Everybody's okay? So we can say 1 pi is equal to 2 pi times the absolute value of B, which tells us B is equal to a half or negative a half. Are we okay there? Now to figure out the H, is going to be different depending on whether writing a sine graph or a cosine graph, right? That's what we observed from the first problem. So let's say that we're using a sine function. So for sine, what should I be choosing? What kind of point am I going to use to find the value for h? I need to select from my graph a midline point. So for example, any of these would be appropriate. Let's say for the sake of argument, I'm going to pick this one. Is everybody okay there? But it doesn't matter. Any of those would be fine to use. So that point is, it looks like it's halfway between 0 pi and a half pi. So that would be a quarter pi. That point appears to be pi over 4 comma 1. Is everybody okay with that reasoning? Okay. So we're taking 0, 0 from the parent function, and we're mapping it to the point pi over 4 comma 1 in my transform function. So again, what's going on here, I'm taking b times 0 plus h, and that should give me pi over 4. Or really just that pi over 4 is h. Now I'm writing this out because not every time will you have access to, say, a midline point. So it's important that, that you understand like how we're coming up with that h is pi over 4. It is, in the case if you're choosing a midline point, the h value is the x-coordinate from the midline point every single time when you're doing a sine function. That is true. But sometimes if you're doing a problem where we just give you information, you might not know the location of a midline point. Okay. Then we have to do one more thing. We have to figure out whether the a value should be positive or negative. So from the parent function, we have, for sine, looks like this, right? So before, we have a minimum, then we go to midline point, and then we go to a maximum. In our transform function, we go maximum, then our midline point, and then our minimum. What does that tell us about the sine of a? Did a reflection take place? Yeah, right? If the maxes and mins are in the opposite order from the parent function, the only way that happens is if the parent function got reflected across the x-axis. So we know that our a should be negative. Our k is this. We're always going to pick our b value to be the positive one for sines. There's no sense in trying to make it negative. You could, and you can get an answer out of that, but let's not. And we have our h. So if we put that together, we can say y equals negative 1 times sine of 1 over 1/2 x minus pi over 4 plus 1. Now, you could simplify that a little bit, right? Like 1 over 1/2 is just 2. But when I'm writing my notes, I don't usually do the simplifying because if you guys go back and look at this, maybe it wouldn't be entirely clear where the 2 came from or whatever. I want to make sure that it's as obvious as you can make it for when you go back and look at these again. What if, for example, we had chosen to do this as a cosine graph instead? So for cosine, the parent function we're choosing is the point 0, 1, which is a maximum. So from the graph, I have to pick another maximum or minimum. It doesn't really matter. So any of those points would be appropriate to use. Which one of them seems like it's going to be the easiest one to use? I would choose this one. Because what do you notice about the x-coordinate of this one and the x-coordinate of our parent function? They are the same. So that tells me immediately that h has to be 0 since there's been no shift left or right. Our maximum is still at the same x value. Is that clear? Why I was able to skip doing anything there? And since we're going from maximum to maximum, we know that the a has to be positive. Everybody's okay there? And for cosine graphs, the b doesn't matter, so let's always just pick it to be positive as well. Oops. So there's an answer for a cosine function. Is that our only answer? Heck no, right? If you picked a different maximum or minimum, you'd get a different answer that would be equivalent, still correct, no less correct, but you have a lot of choice there. Everybody okay with that? Okay. Let's do another example, this time where instead of giving you a graph, we're going to give you some information. So this says construct a sinusoid. When we say sinusoid, we just mean a sine or cosine function that has an amplitude of 4, a period of 3 pi, and passes through the point 3, 1. So if our amplitude is 4, what does that tell us? A is 4 or -4. If our period is 3 pi, what does that tell us? Well, it's going to tell us about the b value, right? That I know then the period is equal to 2 pi times the absolute value of b. So b is just going to be 3 over 2 or -3 over 2. Is that okay? Now we're left with this point 3, 1. Do we know anything about this point 3, 1? All we know is that the graph has to go through it, right? So if we're writing a sine function, what would be the best kind of point for 3, 1 to be? A midline point, right? If we're writing a cosine function, what would be the best kind of point for 3, 1 to be? A maximum or minimum, right? That's what we needed to find the h values for each of these. So let's pick that to be a maximum. It doesn't tell us what kind of point 3, 1 has to be, so we have the freedom to make it anywhere, cross anywhere we want in our graph. It's the easiest if we do that, because in this case, we know that the h is just going to be the x-coordinate, and the k is going to be the y-coordinate. Similarly, we know that the h is going to be the x-coordinate. The k, though, is going to be a little bit trickier. So remember, we're going from 0, 1 in my parent in our parent function to the point 3, 1 in my transformed function. Well, to do that, I'm going to take a times y plus k has to give us 1. So since we're going from a maximum to a maximum, I know that a needs to be positive. So here I get that k is equal to -3. So for my cosine function, I have 4 cosine of, the sign of the b doesn't matter, I'm just going to pick the positive one, x minus 3, and then minus 3. For sine, I'm going to pick the b to be positive, and the a, we don't know any other information about what's going on about the maximums or minimums after this midline point, right? So the a could be either positive or negative. It doesn't really matter in this question. It's still going to satisfy the requirements that it has amplitude of whatever, period of whatever, and goes through this point. Like whether that's, it's going like this, or it's going like this through that midline point, it doesn't matter. So let's just, for the sake of argument, pick positive 4. And those are just, again, one set of answers for something like this. You could have lots of different possibilities there. But this is the easiest way to do it for each of these respective types. Keep in mind the question doesn't ask you to write both a sine or a cosine, so it doesn't really matter which one you choose to do. Certainly the sine seemed like it was easier because the h and k were just the x and y coordinates from the midline point. Was that okay, guys? Okay. Let's do another. Okay. Here we have construct a sinusoid that has a minimum value of 510, and its next maximum is at 1532. So I would start by just kind of drawing a little bit of a picture to visualize what's going on, because here we're given some very specific information about the kinds of points that we have. So I don't know, like 5 to 10 would be here, and like 1532 would be there. And we have like that much of the graph that we know about. So it's kind of doing one of these. Is everybody okay there? Okay. So it should be easy to see how to find the amplitude, right? The amplitude is just this distance. So 32 minus 10 divided by 2. That's 11. So A is then 11 or negative 11. Is everybody okay with that? The K should also be pretty easy to come up with. The K is going to be that midline point. So it's really going to be kind of like the average value. I think that was in fact the way we defined the midline point, was like the midline was like the average value for the function. So I'm just going to take the y max and y min, add them together and divide it by 2. So it's just literally taking the average of the max and the min, y coordinates. Is everybody okay with that? Now let's find the b value. To do that, we're going to need the period. So how much of a period is this distance here that we've covered from max to min? Looks like half a period to me, right? Do you guys agree with that? So I can say that 15 minus 10 is equal to 1/2 the period 2 pi times b. So 15 minus 5 is 10. 1/2 times 2 pi absolute value b is just pi times b. So I divide both sides by 10. I'm sorry, by pi. So there's my b value, 10 or negative 10. Or, I'm sorry, 10 over pi or negative 10 over pi. Is everybody okay with that? So now we're just left to come up with our h. So if I'm doing a cosine function, that would be the easiest situation, because I can go from 0, 1, my max, to 15, 32, which is also a maximum. So I know that the h is just is the x coordinate, and the a has to be positive. So I can say I have y equals 11 times cosine of 1 over 10 over pi times x minus 15 plus 21. Is everybody okay there? Elizabeth? Sure. Now, if I wanted to do this same thing for sine, this becomes a little bit trickier because I don't know a midline point, right? So I would have to use either a max or a min from sine. So if I looked at sine, the maximum occurs at pi over 2, comma 1. So going max to max. So my b is 10 over pi times pi over 2. That's my x-coordinate, plus h. Should give me 15. So 10 over pi times pi over 2 is just 5. And if I subtract 5 from both sides, I get 10. And I can now, because I'm going max to max, a has to be positive as well. If I pick the minimum, I would go minimum, or a would be negative, excuse me. So I can say that. Ah! That was supposed to be sine. Okay. So we're going to stop here. That's probably good for today. From the chapter problems, you guys can do 7 through 8. Excuse me, we already did 9. And do 13 and 14. And then we should be able to do double check here. Oh my goodness, I'm in the wrong notebook altogether. Let me hold on a second. Cut. Okay, so we're being stubborn right now. Wowzers, wowzers, zozers. Okay, so that's in the right place now. Crisis averted. And we should be able to do worksheet 2 and worksheet 3. Yeah. So those will be due on Sunday at the next homework check. You guys can take the rest of our time, the next 25 or 30 minutes that we have here in class, to work on these things. And we'll probably find some time next class period to work on this as well. I know some of the questions on here get quite tricky, and it's often, I think, quite helpful for you guys to be able to talk about these things with each other or ask me questions as they kind of come up to get you on the right track. Because there's a lot of just kind of, we have to think about what's going on in this situation. It's not just like a rote procedure over and over and over again. So we have to really kind of think about what's going on, and that is not always easy at first to kind of get the hang of how to think about things. So I want to make sure we have some time in class to practice this, that you can ask questions and get them answered, and kind of talk about what you're, oh, I did this, did you do this, and all that kind of stuff, which I think is really positive and helpful. Okay? Cool. So I'm going to leave you guys alone. Go ahead and